graded Math 7-8 students. We are now officially starting a new module, and the new module that we are going to start with is 8th grade geometry. And the title of our lesson for the very first lesson is called, sorry, hold on, let me get there. It is called The Ins and Outs of Basic Rigid Motions Translation. So we're going to write that down. The ins and outs of basic rigid motions. And the first one that we're going to talk about is translation. Translation. Okay? And you have to put that on whatever page number it falls on for you. Okay? And while you're finishing that up, if you pause it, I'm going to get the iPad together. And here we go. All right. The ins and outs. Let me turn it this way, actually, because I think we can get a better view with it this way. Yeah. Okay. The ins and outs of basic rigid motions. And we're working with translations. So something that I need to disseminate to you or tell you is there are actually 3 types of rigid motions that we're going to be working with in these first 3 lessons. And this one that we're starting to work with is called translation. So our goal, today we will learn about transformations that are caused by rigid motions. Rigid motions in geometry mean some kind of movement. And rigid means that they follow a specific order in the way that they are done. The question that I want you to think about is, what is the tool we can use to help determine the length and the direction of the rigid motion? All right, so to get started, I want you to take a look at the what's happening. So we have a picture of a house here, and you notice when the house is standing a certain way, the letter R is written how we're used to seeing them. And then, all of a sudden, some kind of transformation happened, and now our figure looks different. Okay, so I want you to think about that. What would have happened? What do you think we did to that? Okay, in the second one, here's the second picture that I have for you. So I have a new figure, heart, with an S in the middle. And then that same heart now is over here. Still looks pretty similar. Has the S going the same direction, but it's in a different location. So what do you think happened there? All right, and then the last one I want you to look at is we had an arrow that we started right here. Okay, it's labeled B. And now all of a sudden that arrow has something done to it, and now it's looking backwards, except the B is going the same direction. So that's a little bit interesting. I think the B was supposed to go backwards too. So the question that I'm asking you is, how have the figures changed? All right, so hopefully you guys have had a little bit of practice or exposure to what happens to shapes when they do this. But we're going to learn about the correct mathematical vocabulary that describes each one of these. So in this first picture right here, just to help you understand, this one is called a rotation. So basically what we did to the house is we picked the house and we spun it around until it was there. So that's called a rotation. This one with the hearts is called a translation. And what a translation means is that we split it from one spot to another. And then the last one is called a reflection. And what happens is we took the arrow and we just went flip and flipped it over. Okay, and so that's called a reflection. So this little picture right here that you see is actually an example of all 3 transformations of the basic rigid motions that I was telling you about. Okay, and so today, if we go back up here to our title and to our goal, we're going to be specifically focusing on translation. Okay. So, moving on, things to know. Transformations are when a figure moves from one location to another and has changed. So you start out with the shape that you start with, and then it moves and it changes in some way, whether it's its location in the plane where it was, whether it was turned upside down, or whether it was flipped across something. It changes. Okay, and that's what a transformation is called. So a transformation in math is how you identify how a figure has changed. Okay? And the way we need to keep track of this is we have them called the preimage, And this is a vocabulary word that you need to start to remember and try not to get it mixed up, because these terms are what we're going to use throughout this whole entire module. So preimage is what we call the original figure. So that means that original picture in the way that it was is called the preimage. Image is what we call it when it results due to a move or a change to the original figure. So it's called a preimage before the change, and it's called an image after the change. Okay? The next thing that you need to know is the word map. Now, some of you have heard of maps and you think of a picture of a map that shows you something. Well, that's kind of like it. But in math, when we say the word map, we're talking about how are we going to change the preimage to map to the image. So that's our job as mathematicians, to figure out what happened to it. What was the change? Was it a translation, a slide? Was it a rotation, where it turns? Or was it a reflection, where it flips? So what we call it is mapping. So we would say up here, this arrow is mapped to this arrow by a reflection. This heart is mapped to this heart by a translation. This house is mapped to this house by a rotation. So mapping tells you you're taking your preimage and you're figuring out how it became the image. That's what mapping means. Okay? All right. Transformations have a specific way to writing them to show that the figure has been changed. There are certain types of written notations. We use tick marks and function notations. There are three main types of transformations that we'll be focusing on first. The first one, like I said at the very beginning, is a translation. And this is where you have to write the definition of a translation. So a translation is, get your pencil out, get ready. A translation is when you slide the preimage to the image position. Okay? So a translation is when you slide the preimage to the image position. Okay? Translation. So something that you could write there that would help you remember is that a translation is a slide. Okay? A lot of times what we're going to do when we do a translation is we are going to use a tool called a vector. Okay? And so if we go back to that picture, and I'm going to move the iPad in just a minute. Okay, I'll do it right now. If we go back to that picture, we had a heart, and inside our heart was an S. So a translation uses a specific tool, and the tool that we use is called a vector. And so what we do is we create a spot that is next to the figure, and then the vector tells you how long the translation has to be. And so what you're going to have to do is we're going to use our transparencies to help us with this. That's why I said, remember I told you a long time ago, keep your transparency because we're going to have to use them. And lo and behold, what is it? Hold on a second. Let me go grab mine because it's in a different spot. Go over here and grab it real quick. Sorry. I forgot. So we need our transparencies. You take your transparency and you set it right on top of the original figure, and you are going to trace the figure and the vector. I'm going to trace my figure. Here's my figure. I'm going to trace my vector, making sure that I get my ending point and my tip of my arrow, because remember, your vector tells you how long you're supposed to go, and I'm going to slide it right along that vector until I get to the point. And so now, where that new position is, this is called the image. And so when we draw it, we would draw that this image sits right right there. So my new image is sitting like this. Okay, so let's try it again and see if I matched it pretty well. Ready? I'm mapping S to S prime. Pretty good. Okay, and this is actually changed with a little tick mark. We've been talking about that for a while, and that's called prime. Okay, so this is the preimage. Remember, using vocabulary so you learn it. This is called the image right here, and we can also call it figure S prime because it's a new image of the old one. Okay, so this is called a vector. That little arrow is called a vector. You might want to remember that, especially for our question of our lesson. So let's go back over here to our vocabulary on our notes and what you need to know. So a vector is a tool that we use in geometry to show the length of a translation, okay? And it's in the form of an arrow. It has an endpoint with the arrow on the end. Prime notation is what I did to the S in the image where I put that tick mark. Remember, prime notation is the tick. The number of ticks tells you the number of changes, okay? So we only changed that heart one time, so I put S prime. If I had moved it again, then it would be called S prime prime, okay? So prime notation is not a new word for you. You guys know what prime notation is, so that's what prime notation is. All right, the thing you need to know about translations is translations map lines to lines, rays to rays, segments to segments, and angles to angles. That's what translations do. Translations preserve the length of segments, and they also preserve the measures of angles. So this is going to come in handy when we're talking about triangles and having to move them. Your triangle is not going to change in size because the only thing that's happening to it is it's sliding from one spot to another. So let me go over that one more time. Translations map lines to lines. The lines don't get longer. They just go to another spot. Rays to rays. Again, don't get any longer. They just go to another spot. Segments to segments, and angles to angles. All of those are preserved when they move. You draw them exactly the same. So preserved means they have to stay exactly the same. Okay? And I believe that's all we have in our notes today. We're going to do a lot of practice with this, so I don't want you to feel overwhelmed. It's a lot of new vocabulary and a lot of new information, but I think you're going to have fun with it. Remember, bring your transparency, and I have your markers for you because we're going to need them. All right, that's all that I have. Oops, I forgot. Let's go back over our question really quick to make sure that we accomplished our goal. Our goal for today. Today we will learn about transformations that are caused by rigid motions. I feel like we did. And our question is, what is a tool that we can use to help us determine the length and the direction of a rigid motion? I gave you a little hint. Hopefully you can answer that. And that's all I've got. All right, talk to you soon. Bye.